everyone, this is Brian Fraser with Adamson Systems, continuing the Blueprint AV tutorial video series. In the last episode, we looked at the basics of using the 3D space. Now, let's look at how to design in the 3D realm. In the 2D realm, we are chiefly concerned with how an array behaves in the vertical plane. This is arguably the most important aspect of array design, especially when it comes to quick load-ins. In situations where more time is available and when an architectural plot of the space you'll be using is obtained ahead of time, it's desirable to recreate the entire space exactly. Let's begin by starting a new design file by selecting New Design from the File drop-down menu. Add a stage to this design by clicking on the Room Data tab and then selecting the Stage subtab. Click the plus button to add a stage. From here, you can name your stage, choose what reference axis the stage will be positioned according to, activate your stage, which includes its use in a simulation, mirror your stage on the X or Y axis, alter the initial position of your stage, choose from two common stage shapes, and determine its dimensions. Note that if you leave the front and angle position fields blank, the stage front will default to a position of 0 and 0 on the X and Y axes. Let's assume the space we are building has a stage that is 15 meters deep, 20 meters wide, and 1.5 meters high. After entering these values, click OK. This particular space will be modeled after a traditional theater that expands in width. Click the Floor subtab and add a floor group by clicking the plus symbol. Name your floor group and set the audience to Sitting. Now click the plus symbol beside Surface to add a surface. You can see that the color coding of your vertices in the 3D view corresponds to the color coding in the left-hand coordinate view. In the field, you could use the 2D calculator to determine your surface areas, as discussed in the second video in this series. We will go over how to adapt the use of the 2D calculator to the 3D workspace in upcoming videos, but for now, let's assume that you have a design file to draw your data from. Let's assume this room is symmetrical. Center your surface on the x-axis and enter 40 for x and 20 for y in the coordinate entry field of the yellow vertice. Now enter 10 in the y-coordinate entry field of the red vertice. Note that clicking the y box under center will mirror your selection on the y-axis, changing the x-axis coordinates of your red and green dots. This can be useful when building arenas or stadiums where the stage is centered, as well as numerous other applications. Now create a second surface. You will notice that on the left-hand coordinate view there are several buttons labeled E or V, 0, 1, 2, and 3. These buttons activate the linking function. The E stands for edge and the V stands for vertice. Click the E0 button and hover your mouse over the original floor section. You will see that the surface now has dotted white lines around it, so hover your mouse over the far edge until it becomes a solid white line and click on it with your left mouse button. You can see that Blueprint has now matched the edges of the two surfaces together. Make sure you click E0 again to disable the linking function. Center your second surface on the x-axis and enter the following values in the yellow vertices coordinate entry field: 70 for x, 30 for y, and 8 for z. You now have a basic 3D model. In the next installment, we will look at some of the other shapes available to you in the Floor subtab. Please stay tuned for the next installment of the Blueprint tutorial video series.